Triangle congruence. Today, this one we're going to talk about side angle side and side side side. So once again, remember that in order for triangles to be congruent, you have to be able to prove all corresponding angles are congruent and all corresponding sides are also congruent. So everything's congruent. And once again, remember you don't necessarily have to prove all of that. You just have to prove some of it, and then we can make assumptions about the rest. All right. So last time we talked about angle side and angle side angle. Today we're going to talk about side side side, or SSS, and then side angle side, and then we're going to briefly talk about hypotenuse leg, which is kind of inferred based on what you already know about the Pythagorean theorem. All right, so side side side, if all three pairs of corresponding sides have equal lengths, then the triangles are congruent. This has to do with basically the ratio between those sides and the angles has to remain constant. So if these sides are the same and the opposite side of all the sides are the same, those angles have to be fixed in place. So they have to be identical for both triangles. If one of the side's length changes, all the angles change. And again, like I said, that would break the side 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 rule, which would mean they're no longer congruent. And a lot of students are like, what if I change the side length? Well, then I'm not telling you it's congruent because I'm not stating it's side, side, side. But if if everything's the same, if all those three sides are the same in both triangles, those angles will also have to be the same because it's a fixed ratio, right? It's not going to change. It's a set object, and they have to be the same at that point. Okay, the next thing we need to talk about is side angle side, or SAS. If two pairs of corresponding sides have equal lengths and the corresponding angles between them, the included angles have equal measure, then the triangles are congruent. So if we have, this one's a little harder, so I'll go ahead and highlight our corresponding sides here. So if this side is the same, and this side is the same, right, and then these sides right here are the same, and then the triangle, or the angle between them is the same, then they are congruent. And if you think about it, if these are fixed, right, that's a fixed length, that's a fixed length, that's a fixed length, that's a fixed length, and the angle is the same, that actually means that this has to be the same length. Now, if you think about like a door that has the same, you kind of think about like if you look at a door, and most doors are uniform. So if you look at a door in a school and you're open each door at 45-degree angles, and then you take a string that goes back from the door to the door jamb, the length of that string is basically going to be the same for every door in the building, right? Provided you open at the same angle. Now, if you open one more than 45 degrees, right, the string length is going to be longer. If you close the door, make it less than 45 degrees, the length is going to be shorter. But as long as you keep it fixed at 45 degrees for all the doors, you're basically getting, if you kind of take where the door originally started at, make a line there and open it, you're basically getting a whole bunch of congruent triangles. So kind of the same basic idea. As long as those angles are fixed and those sides are fixed there, they're going to be congruent triangles. Okay, hypotenuse leg is the last one. This one we're not going to really talk about more than this because we're all familiar with the Pythagorean theorem. If we know a hypotenuse and one leg of the right triangle have the same lengths as the hypotenuse and the leg of another right triangle, the triangles are congruent. If you think about it, if we know the hypotenuse and we know a leg, that means we have enough information to go back and solve for the missing leg, which means quickly we can go from hypotenuse leg to this idea of side, side, side just by doing a quick calculation. So hypotenuse leg is essentially the same as side, side, side because if we know two of the items in a right triangle, we can find the third. Okay, let's go ahead and now, question, why isn't it leg, leg in a right triangle? Because, well, that would be side, angle, side, right? Because we know that the legs are attached to the right angle. So basically, a hypotenuse leg is a way of looking at side, 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 or, yeah, the alternative is basically side, angle, side. So, good. All right, let's look at some examples, same as we did last time. So we're going to determine if the triangles are congruent based on, this time we're looking at the SSS or the SAS. There's no hypotenuse leg examples in here, so we can omit those. Okay, so first off, let's look at this first example. We have congruent side lengths based on how they are denoted or marked, right? And then we have a shared side. Since it's shared, it also has to be congruent. And then we have a right angle connecting those, all right? So in this case, we have a side, an angle, and then a side. So we can say this is side, angle, side. All right. Okay, next one we're going to look at here Okay, so we have a denoted side. We have another side here because it's marked. And then once again, we have a shared side, right? So all the sides are the same. So in this case, this would be a side, side, side. Okay, next example. Okay, we do have a angle that's the same, which is good. And then we have a side that's the same. And then we have another side that's the same. But let's look at the order here. So this one would be side, angle, side. This one would be angle, side, side, right? I spell another bad word. This is a bad word when it comes to triangle congruency and in the real world. So this does not work. I mean, even if I had another one that had the angle, side, side, it wouldn't work because there's no guarantee that the last slide is going to be the same length as we have variability with that angle. Anyways, we don't have enough information to prove that these are congruent. So I think in this case, it's actually safe to say these triangles are not congruent. We did not meet any of the conditions. So angle, side, side, right, doesn't line up. Even though we have congruent sides and a congruent angle, the position of the congruent sides and congruent angle has to be considered. Remember, the angle has to be between the two congruent sides for it to work. All right? Okay, so keep that in mind. Last example. Okay, we have a congruent side here. We have a congruent side right here, as it's denoted by that. And then finally, we have a congruent side here. The longest side of this triangle is also congruent. So we have a side, side, side condition. So we have satisfied our conditions for congruence here. So we can say that these two are congruent via the side, side, side theorem. All right, thanks for watching and have a good one. Bye.